the production of quality of crossbreed silk. HRD at the training division, CSRNT Mysore, Sericulture Training School of DOS, Karnataka and KVK, and a different training program for farmers, officers and staff. Dr. Dayanand has recognized and awarded for his significant contribution in the development of L14 into CSR2 and ME1 into S8, and an improved crossbreed for cocoon productivity and silk quality suitable to power looms. Dr. Dayanand has been attended 16 national conference and presented paper. He has 18 research papers published in national and international journal and 19 papers in conference proceedings in his credit. Further, Dr. Dayanand is also served as a member of Board of Studies in Department of Studies in Sericulture Science PG and Yuvraj College UG Mysore. He also served as external examiner PG besides involvement in revision of syllabus for MSc course University of Mysore. With this, so I welcome you, sir.
Thank you.
And podium is actually hand over to Dr. Dayanand, sir.
Okay, thank you, Dr. Anil Kumar, for a lengthy introduction. And very good morning to all the delegated participants. Of course, I am seeing on the screen many of our gurus and some of my colleagues and friends. And first of all, I would like to compliment the University of Mysore Authority for providing this online platform to conduct this type of webinars. And it's also my great pleasure to extend my thanks to faculty members of the Department of Studies in Sericulture, University of Mysore, Professor Sanappaji, the chairman of the department, and Dr. Manjunath sir, and Professor Anil Kumar, and other person who are directly or indirectly involved in organizing this webinar and providing me an opportunity to at least to see the faces of our seniors and my friends on screen. I have also been attending the webinar since from the beginning, organized by the department and presented by eminent personalities in the field of sericulture, since from Dr. Kumareshan, Professor Mamata ma'am, and Dr. Satish Verma, and Dr. PJ Raju sir, and Dr. Tippeswamy sir, so on. And all went well. And their presentation actually motivated me to present here. Thanks. I also extend my thanks to them also. So coming to my presentation, without further wasting my time, the share button. The title of my today's presentation is Breeding Strategies for the Development of Silkworm Breeds Tolerant to High Temperature and BmNPV. And during my course of presentation, you'll come to know why I have chosen only this high temperature, of course, the high humidity and BmNPV as the factors. So for better understanding, so I just pose on 5 questions before you. And they are, what is the strength of sericulture in developing rural development? And the present status and future goals of our sericulture industry as far as our silk production is concerned. And what are all the contributors play a role to reach our goals? One among the contributors may be the development of silkworm breeds tolerant to stresses. And while developing such type of breeds, what are all the difficulties we will have, and how to overcome to a little extent. You cannot overcome completely. To certain extent, how to overcome that difficulties of conventional breeding through using the molecular tools. Coming to the first point, the merits of sericulture or the strength of sericulture in developing rural areas in India. You know, the sericulture is an agro-based cottage industry, occupies an important position in Indian economy owing to a high employment generation. Actually, we are having a plan of providing 150 lakhs person by 2030. And high and regular income, maybe at the possibilities are there to get the income at the monthly basis. If the farmer divides his mulberry plantation into 2 blocks, he can have 10 crops in a year. That means almost once in a month he will have a revenue. And that next is eco and women-friendly activities. More than 50% of the work, whatever it is being carried out, that too in pre-cocoon technology, pre-cocoon sector, it is carried out by the women. And since we are not using any harmful chemicals especially in the pre-cocoon technology, the activities we call it as eco-friendly. And it transfers the wealth from rich person to the poor. That means the output normally used by the rich people with the resource of poor people. And then value-added products like compost, vermicompost, firewood, spent pupa, and PC cocoon, silk waste. There are a lot of value-added products. And export earnings, of course, we are having a plan of reaching 4,000 crores by 2030. And effective in practicing integrated cropping system. As I already told, we are not using any harmful chemicals in the cultivation of mulberry as well as silkworm rearing. So in addition to silkworm rearing, we can have the animal husbandry, fishery, and even poultry also. And the next one is the effective land utilization. Nowadays, you know, the land is the limiting factor. So as far as the agriculture terminology, agriculture definition is concerned, if any land is being using effectively means it should have 3 types of crops. One is short term, then medium term, and long term. So our mulberry, once if we plant, it gives you around 50 to 20 years the leaf yield continuously. So it acts as a medium term crop. And since nowadays we are recommending a wider spacing of mulberry cultivation, even up to 10 by 10 spacing, we will have plenty of space in the garden, in the mulberry garden. So with that, we can grow some leguminous plants. So it acts as the short-term plants. And moreover, on the boundaries or even the wider spacing, if you plant some valuable trees like coconut, or it may be teakwood plants, so it will serve as your long-term crops. So with this, we can say this sericulture is an ideal instrument for the development of rural India. Coming to the present status and future goals of our sericulture industry as far as silk production is concerned. So many of my previous presenters have already given this information. That one of my friend still he has elaborated and given the target our goals up to even 2029-30. Okay, but purposefully or logically, I have taken here some 6-7 years. I have taken year 2016-17 or the base year, the achievements. So after completion of 3 years, that means by 2019 by 20, where we are, what is our achievement against the target, and the remaining 3 years, what will be the goal? To achieve that goal, whatever the speed or we are going, whether it is sufficient or it needs to be geared up. See here, 2000 after completion of 3 years from the base year, as far as the mulberry raw silk production is concerned, we have achieved 25,239 metric tons as against 27,000 metric tons. So there is a gap of 1,761 metric tons. It indicating around 6.5% lagging. That means still behind. And similarly, in the 1 year silk production also, we have achieved 10,581 metric tons as against 11,530 metric tons. So it has a gap of 949 metric tons, indicating 8.2%, nearly 10% still shortfall is there. And as far as total raw silk production is concerned, we have achieved 35,820 metric tons as against the set goal of 38,530 metric tons per annum, and shows a gap of 2,710 metric tons. And overall, still we are having a deficit by 7% in case of mulberry, in case of total raw silk production in India is concerned. So in order to achieve this, we have fixed some milestones. Up to 2030, we have fixed a milestone. Since from a mulberry expansion of mulberry area, that we are having a plan of reaching 3.86 lakhs hectares of mulberry by 2030. Mulberry leaf productivity from now 45 to 50 kg, we are in that range. We have go up to 55 to 60 metric tons per year. And seed production, we have to achieve 5,804 lakhs by 2030 to achieve our goals. Yield improvement, 65 to 70 kg per 100 DFLS. Renita, we have to bring down from 7.3 to 6.5. Raw silk production, similarly, that is, we have to go up to 110 kg per hectare per year. Employment, 150 lakhs persons. And see, absolutely, there will not be any silk import by 2030. That is our goal. And export earnings, we have to earn up to 4,000 crores. So with this, we can say the mission of the R&D institutions may be owned by state government or the central government, including the universities who are holding the responsibility of sericulture development in the country, is to enhance production, productivity, and quality of Indian silk. These are all the three aspects one has to look forward: the production, productivity, and quality of Indian silk. So in order to achieve this, we should have a silkworm crop success in the field. There should not be a crop failures in the field. Crop failure in the field which adversely affect on these three parameters. So we have to maintain the consistency in silkworm crop success in the field. So with this, what type of breed we should have? What are all the contributors play a role in silkworm crop success in the field? See, major contributors will be the mulberry leaf. It accounts for 38.2%, followed by the environment, that is rearing climate. It contributes about 37%. Then rearing management, seed, and the breed. Of course, the others also will contribute around 6.6%. So the breed. So here, see, the climate along with the breed will have a contribution of 42.2% in crop success. So that means the silkworms, what we are having or what we supposed to have, they should be a productive in nature. They should be qualitative in nature. They should tolerant to abiotic stresses and tolerant to biotic stresses. So this is how our breed should be. But we cannot develop the breeds universally with qualifying all these four characters. So then what is the need of the hour? Depending on the situation, we have to develop the breeds. So why this productivity? Why this our breed should be productive? Why that our breed should have qualitative traits? Why they should have tolerant to biotic stress and abiotic stress? See, coming to this production and quality. See, production, it is required to meet our demand and supply to make India silk self-sufficient. So our requirement has to be satisfied by domestic production only. So then why quality? Quality in order to meet the requirement of power looms and mechanized hand looms, especially these power looms and mechanized hand looms, more particularly for the warp threads, that silk should have very good elasticity and tenacity, or otherwise that they cannot withstand the pressure force during the weaving process. So for that point of view, we should have a quality raw silk. The second thing is, in future, we may be the major silk exporter in the world. Now China, now if you see the statistics of China, their raw silk production is coming down year by year very drastically. Very drastically it is coming down. So maybe in future, they may not be meet out the requirement of silk by the other countries. So we will take that chance. So in order to export our, by knowingly, by fortunately or unfortunately, if our raw silk production is more than our requirement, then the surplus silk, fate of surplus silk is questionable. So we have to export the surplus silk production. That means that silk, whatever we are supposed to export, should qualify or should fulfill the norms of international standard. So next, these two things will make India silk self-sufficient. Moreover, the other third point is there, that is productivity. If you increase the productivity, the cost of production will be reduced. Thereby, the farmer net income will be more. So then how to increase this production? There are three ways to increase the production. One is by horizontal expansion. That means expanding the mulberry acreage and seed production proportionately. So you will get more silk. And vertical expansion, that means to increase the production per unit area, that is productivity. See, the production of cocoons per 100 DFLs is around 50 kg in India. But it is more than 70 kgs in China. What it indicates? It indicates that the country, that means we are consuming more mulberry acreage, more layings compared to China to produce same quantity of raw silk or the cocoon. If we had higher productivity, we could reduce the egg production and mulberry acreage to avoid more burden, also to avoid more burden on them. So the third way of increasing the production is to reducing the crop losses due to silkworm diseases and pests. Now the survey says the crop loss is around, due to disease, is around 15 to 20%. And more than 50% of the crop loss to disease is because of this NPV. All the crops, farmers are losing because of this grassery. Of course, now release of improved mulberry varieties, productive silkworm hybrids, and improved agronomical practices, coupled with crop protection measures and appropriate rearing and reeling technologies, it has changed the sericulture scenario in the recent years in terms of silk production. And we have developed many number of productive biovoltaic single hybrids and double hybrids. Of course, even the improved crossbreeds having a potentiality to produce quality silk suitable for power looms and handlooms, but their full potentiality in the field is yet to be exploited due to various reasons. Of course, they are known for their productive merits, whatever the new breeds and hybrids we have developed. This absence of genetic plasticity to buffer against tropical environmental stresses act as a constraint to exploit the full economic potential of these hybrids. They suffer badly in the adverse conditions of the environmental stresses. The environmental stresses may be of biotic or abiotic. So coming to these abiotic factors, as far as the growth and development of the silkworm is concerned, the temperature, humidity, air and light act as a major biotic factors. This temperature and humidity, the silkworm grows well with a wide range of temperature, say about 20 to 30 degrees centigrade temperature and humidity of 70 to 80%. They grow well, silkworm grow well without any significant difference. And the temperature and humidity below this prescribed range only affect the growth and development of the silkworm. It may have direct effect or it may be having indirect effect. Maybe now because of this global warming and also climate change, it has resulted in universal rise in temperature. What happened, this many quantitative characters of cocoon, maybe cocoon weight, shell weights, they decline sharply at a temperature, rearing temperature of higher than 35 degrees centigrade, rearing temperature, that is microclimate. So as far as tropical country is concerned, normally the temperature below 20 degree, maybe it is a very unusual and very few months in a year and few days of a month and few hours of a day, you may come across with this low temperature. And low humidity, of course, it will be there during summer and winter, but it can be managed by a simple rearing practices, by sprinkling the water and then keeping the surroundings cool. So we can, low humidity can be managed. So you can increase the humidity. And management of high temperature and high humidity, it is nothing but air conditioning. And managing these two things are highly expensive. We cannot affordable. That cannot be affordable. And coming to air, no, the optimum speed of the air in the rearing house, 0.5 meter per second during rearing. And of course, 0.1 meter per second during spinning is recommended for good growth of silkworm and to spin quality cocoons. You know why that air is required? There are accumulation of poisonous gases due to respiratory activity of silkworm, and there will be a litter and so on. So there will be accumulation of carbon dioxide and ammonia. These two gases are poisonous as far as the growth and development of the silkworm larvae is concerned. So these has to be driven out from the rearing house. Low aeration in this rearing house lead to built-up humidity and accumulation of these gases. They adversely affect growth of silkworms, especially on pupation. And it can be managed by single, this air is there, very air is there, but only that has to be managed as per the requirement. So the air is not the problem. And of course, light, though we have an optimum of 16 hours light and 8 hours of dark is recommended for silkworm, slight variation in light during silkworm rearing may not have any adverse effect on commercial point of view is concerned. Only some seed rearings may have some effect on hibernation. Such things will be there. But as far as this commercial point of view is concerned, for commercial rearing is concerned, it will not have any adverse effect. with slight variations of this. So the point is now, so management of high temperature, high humidity, and their combination is the challenge before us. So then with this, that's coming to the biotic factors. This, like other insects, pathogen causes disease to silkworm and led into the considerable crop losses in the field. And the silkworm is affected by large number of diseases caused by virus, bacteria, fungus, and protozoa. This fungus causes muscadine, virus causes grassery, and bacteria causes flachere, and microsporidium causes febrile disease. The crop loss due to incidence of disease is one of the major problems encountered by sericulturists of India. Unlike in other countries, other sericulturally advanced countries, the pathogens with us are alive in the environment continuously because of continuous availability of the host. Throughout the year, silkworm mulberry will grow and will have a silkworm rearing. That too, the haphazard way of silkworm rearing. In a village, if you go, you will get all stages of sericultural activities will be going on. So the pathogen will get the continuous availability of the host. So the silkworm pathogens survive continuously in the environment and always they remain infective. Of course, now introduction of productive. On the other hand, now we are introducing bioltines, that is the exotic breeds, which are more susceptible to the disease, is also one among the reasons for crop losses due to diseases in the field. They are very susceptible. And nuclear polyhedral disease caused by this virus is predominant in the field. Nearly 20 to 50% of the crop loss due to various diseases are accounted by this grassery disease caused by this BmNPV. The main reason for that is the sturdy nature of this polyhedra helps widespread of grassery infection in the field. Of course, disinfection hygiene forms an integral part of the healthy and successful silkworm rearing. But the problem is this inadequate disinfection and unhygienic conditions in the silkworm rearing environment. This use of commercial silkworm breeds and hybrids, which are resistant or tolerant to major silkworm diseases, is a better option. So altogether, this is our need, how our breed should be. It is the need of the hour. So whatever the silkworm breeds and hybrids we are having, they should, or we are going to develop, these 4 parameters we have to take into the consideration. Those breeds should be productive in nature, qualitative in nature, tolerant to BmNPV. Of course, we have left other pathogens because it plays a major role in the crop losses. That's why we have taken only that BmNPV, and tolerant to high temperature and high humidity. Since low temperature and low humidity can be managed with simple rearing practices, so the difficulties are there only to manage high temperature and high humidity. So we have taken this tolerant to high temperature and high humidity. This is the type of breed or silkworm breed or hybrid what we want. So our breeding program should ensure the development of breeds and their hybrids which are tolerant to BmNPV and high temperature and high humidity without affecting this cocoon productivity and quality. We have to balance less cocoon productivity and quality and all 100% survival is there, it will not serve our purpose. So we have to balance the productivity and this tolerance to biotic and abiotic stresses. Generally, this tolerance to high temperature is controlled by a dominant gene, whereas tolerance to BmNPV is a polygenic. And through this conventional breeding, it is very difficult and also it is a time consuming to develop the breeds, breed characters which are controlled by the polygenes. Of course, now using conventional breeding through applying selection pressure, our leadership of our former directors, since from Dr. R.K. Datta sir and S.B. Dandin sir, and Dr. our H.K. Basuraju sir and his team, including Dr. Suresh Kumar, Dr. Kalpana, Dr. Mal Reddy, Ravindra Singh, Dr. Ram Mohan Rao, Premalata, Dr. Raghavan, so on. And they have developed some of the polyvoltines and bioltines for the specific characters. As far as bioltines are concerned, CSR 18, CSR 19, CSR 46, and CSR 47, of course, even CSR 50 also, they are tolerant to high temperature. And another line, these two polyvoltines, that is ND7 and ND5, they have developed for high temperature tolerance. And NP1, once again, it is a polyvoltine, this tolerance to BmNPV. Later, under the leadership of our earlier directors from SMH Kadri sir, and Dr. Bindru sir, and Dr. Shivprasad sir, emphasis was given to improve the polyvoltines and identify the improved crossbreeds where those improved crossbreeds can able to produce even 2A to 3A grade of silk, which is suitable to our power looms and handlooms. This MV1, that is multi-tolerant virus, that is tolerant to all the three viruses, IFV, DNV, and BmNPV. And very recently, with this L3 and HB4, we have developed with the new strategy of breeding, tolerant to high temperature, high humidity, and BmNPV. It is actually the plan of Dr. Shivprasad sir. Luckily, I am also involved in that. So here, how to develop this type of breeds by using conventional techniques. So what we have to do first, we have to collect the maximum germplasm based on the passport data. Now the problem is, see, we are not sharing the breeding resource material. That is the major drawback with us. See, for instance, as far as the multivoltine breeding laboratory of CSR&T is concerned, we are having some 14, 15 this evolved polyvoltines, but nobody is using. Of course, those may not having commercial importance, but they have to be used as a breeding resource material for the development of the new breeds. But see, now they are maintaining here only. They are not giving to the germplasm bank since they are not authorized. This is the problem. We are keeping those breeds. It will not serve our any purpose. So what we have to do, we have to collect the maximum germplasm based on the phosphate data. Their data available on qualitative and quantitative traits, and of course their disease and temperature tolerance. So after collection, we cannot use all those collected germplasm as the breeding resource material. So we have to shortlist them. How to shortlist? For the development of breeds tolerant to high temperature and high humidity, of course, BmNPV, they have to be subjected for the physical stress. One is high temperature and high humidity, and BmNPV. Of course, we are having a standard technique. Of course, maybe different researchers will have a different techniques. But what we were having as from the expertise from pathology, this high temperature, this collected germplasm will be subjected to high temperature, that is 36 plus or minus 1 degree centigrade, and high humidity, plus or that is 85 plus or minus 5, for a period of 6 hours per day from 3rd day of 5th instar till spinning. This is the technique what we were used with the help of Sericulture. And BmNPV inoculation, this collected germplasm will be inoculated with BmNPV at a dose of 1 ml per 100 larvae at the concentration of 1 into 10 to the power of 6 polyocclusion bodies per ml on the first day of 3rd instar. So after subjecting these germplasm to these type of stresses, based on the productive merits of high temperature, BmNPV, and then tolerance level, that breeding resource material will be selected. One important characters we have to see here, that productivity, the productive merits has to be taken very carefully, because these productive merits of the breeding resource material should be always above the average, because these productive merits cannot be improved during the course of our breeding technique, because we are exposing the material to the high temperature and BmNPV, both biotic and abiotic stress. We may not improve the cocoon traits or these productive merits during the course of breeding. So this is the breeding approach we have followed. See, based on the productive merits and their tolerance level to the biotic and abiotic stress, we may have some on the 8 to 10 breeding resource material we may get out of some 30, 40 screened material. So that two parents also we have to identify. One may be productive, another may be tolerance level. The top ranked germplasms we have to take. So we have to conduct F1 rearing, that is the mass rearing. In the F2, we will have a segregation. Population, segregated population will have. In the case of F2, what we have to do? We have to divide the F2 population into two. That first set of the F2 population, we have to screen for high temperature as per the technique what we have I have told. And the second set will be screened for BmNPV. And in F3, what we have to do? We have to reverse the treatment. F2, one set we have given high temperature. The next in F3, the same set has to be go for BmNPV treatment. After giving these two treatment, in F4 generation, we have to conduct a normal rearing, because continuously you are giving the stress. Once high temperature, another time BmNPV, you may lose some of the cocoon characters. So in order to recoup the cocoon traits, what we have lost during this exposure, we have to get it back by conducting normal rearing. That is another treatment. So then we have to repeat these three treatments for 2 or 3 more cycles. If you are having more number of lines, through midway evaluation, we have to, because ultimately we should have a hybrid. So we have to conduct on the midway hybrid evaluation, and we have to shortlist the lines. And then after shortlisting, through inbreeding, we have to isolate may not be a homozygous lines. We have to stabilize the lines. And then finally, we have to conduct the hybrid evaluation and identification of suitable hybrid combination at the laboratory. Once if you identified the suitable hybrid combination, it needs to be in-house evaluation and on-station trials to be conducted as per the authorization protocol. And then pre-authorization trials of these hybrids, compilation and submission of data for the authorization. Nearly about now, as per the new protocol for authorization, we have to generate the data of more than 2 lakhs of particular hybrid. And then see here, see, I already told I have involved in the development of L3 and HB4. See, we have screened 32 germplasms collected from KSSRDI and CSRTI and even germplasm Hosur and even APSSRDI. We have altogether, we have screened 32 germplasm. And depending on the scoring index, top ranked 8 breeding materials we have selected. And luckily, all those 8 breeds were developed by CSR&T Mysore only. And finally, based on the cumulative index, score index, we have got some 5 lines. Out of these 5 lines, we have identified 3 hybrid combinations. That is the crossbreeds. One is L3, that parentage is NP1 into L14 and L14. And another one is this hardy breed HB4. That parentage was BL69 into NDV6. And we have compared these performance of these new breeds with one popular breed, that is pure Mysore, and one improved breed, that is MV1. See, almost all the data is very significant. Except survival, all other characters are having a significant figures. So from fecundity, survival, cocoon weight, shell percentage, filament length, and rendita. And this, once if you identified these breeds, that crossbreeds that we have crossed, we have taken S8 as it is a productive biol type. We have taken S8 male parent as a male parent. And when we cross these new breeds with S8, here also we have got the significant variations between the hybrids, that is crossbreeds. Similarly, we have compared with popular crossbreed PM into S8, and another one is improved crossbreed MV1 into S8. And then, see, what we have done, for our curiosity, these stabilized breeds and the crossbreeds were subjected for both the stresses at a time in a single generation. First, we have given inoculation with BmNPV. Then, during 5th stage, we expose it to the high temperature and high humidity. See, N is normal, under normal rearing, and S is the stress. Stress means high temperature, high humidity, and BmNPV. L3, HB4, these are the new breeds, and we have PM in order to control. See, the larval duration, maybe there is a 1 day shorter in the stress inoculation, in the stress batches. 1 day larval duration, maybe because of high temperature. And there will not be a much significant difference among the survival, single cocoon weight, and shell percentage. Maybe there is a slight reduction in cocoon weight. It may be due to the shorter larval duration. That means it has consumed the less leaf. So it has given back to us the smaller cocoon weight. And all others are almost similar. Even exposing them to all these biotic and abiotic stresses. And similarly, these identified crossbreeds of the identified breeds. Here also, once again, we have taken S8 as the male parent from biotine site. Here also, the 1 day larval duration is shorter by 1 day. And almost see, the survival is an important factor. Maybe slight reduction is there since we are exposing continuously throughout the rearing. That is, in a single generation, we are exposing for both biotic and abiotic stresses. There will not be a significant difference in shell weight, even cocoon weight, and shell percentage. But what is the difficulties for in conventional breeding? Why the concept of using molecular tools coming to the existence? The several important traits, example, increasing disease resistance, have not been handled very successfully in this breeding program so far. The main reason, or one among the reason, is that those characters are a low heritability, and another side, we are having a lack of application of appropriate statistical tool for analysis of such phenotypical data. And the silkworm Bombyx mori, it is infected by many number of viruses, BmNPV, CPV, IFV, DNV. But among these, except DNV, this silkworm resistance of silkworm to these viruses is controlled by polygenes. It is not a single gene. So this is why now the recent developments in silkworm genomic analysis has come into the picture, and it provides the tools and techniques which, coupled with conventional breeding, will definitely help the silkworm breeders or geneticists to perform such tasks. And some of the important modern biotechnical tools are this use of DNA marker, that is selection of parental strains for crossbreeding program based on their genetic homozygosity and genetic distance based on DNA marker evaluation. For this, one of my friend, Dr. Murthy, and his team, and they have evolved some of the tolerant breeds. And then, of course, my friend, Professor Manjunath, is also involved in heat shock protein by using this type of molecular tools. And then this ERA, this transgenic silkworm strains carrying genes for viral disease resistance in identification of cutioles. And Dr. PJ Raju from APSS RDI and Ravi Kumar from our Seribiotech laboratory, by involving the reputed institutions, they have come out with some transgenic silkworm strains resistance to the BmNPV. And 1 foot ahead, now some of our young scientists are going to identify some drugs which inhibits the growth of the virus. We hope for the better one. So whatever may be the technique, whether you are using the conventional breeding technique or the molecular level technique, once if you breed is developed, that new breed is to be put under maintenance channel, and such type of breeds, that means the breeds which are developed for resistance to the biotic and abiotic stresses, they needs to be challenged for such stresses at least once in a year to check whether the tolerance level consistency. That is very important. So what we are doing, we are developing the breeds, and then further by that time the concerned scientists will be transferred elsewhere. No follow-up will be there. That is maybe one of the reason why we are keeping many of the evolved breeds in our laboratory itself. So with this, I can conclude with 4 or 5 on the point. It is the concluding note of my presentation. Sericulture farming has tremendous scope and occupies an important position in Indian rural economy. And the mission of the R&D institution is to, including the universities, I have just forgotten to include, because they are also actively participating in the development of sericulture industry in India. So is to enhance production, productivity, and quality of Indian silk and make India become silk self-sufficient at least by 2030. And for this, silkworm crop success is the primary requisite and backbone for these 3 parameters. Of course, we are having developed many number of silkworm breeds, but their full potentiality is yet to be exploited with the farmers due to various reasons. And the priority before the breeder is to evolve silkworm breeds tolerant to high temperature and BmNPV. It is the need of the hour without affecting its cocoon productivity and quality. And several important traits may not be handled very successfully in traditional breeding. So because of low heritability and lack of appropriate statistical tool for analyzing phenotypical data. So now recent developments in silkworm genome analysis, and of course the identification of drugs which inhibits the growth of the BmNPV. So those things will provide the tools and techniques coupled with this conventional. We cannot simply leave the conventional breeding. We require it because we have to pool the genes. So definitely will help the breeders to perform such tasks. Of course, thank you very much for your patience hearing. So if you have any questions, clarification, you can ask. But if it is possible, I will give my explanation. Or otherwise, my seniors are there. Even I can see on the screen, Dr. H.K. Basuraju sir is there. And one of my friend here sitting with me, Dr. Manjunath, is also involved in development of breeds in these lines. So I will get the answer from them at least. Okay, thank you.
Hello. Hello. If any clarification, please raise your hand. Please raise your hand and ask.
ನೀವೇ ಹೇಳ್ಬೇಕಪ್ಪ ಆನ್ಸರ್.
Yeah. Hereby request any clarification. Any queries? Ananta.
ಈಗ ಟ್ರೈನಲ್ಲಿ ಮಾರಂಗಿಲ್ಲ ಅಂತಲ್ಲ, ಸಾಕಾಗೋಗ್ಬಿಡೋದು ಮತ್ತೆ ರೋಡ್ ಹಾಕಿದ್ರೆ ಟ್ರೈನಲ್ಲಿ ಏನು ಮಾರಂಗಿಲ್ಲ.
ಹೌದಾ, ಬರೋದಿಲ್ಲ ಏನು?
ಬಸವರಾಜು ಅಂತ ಮಾತಾಡ್ತಾರೆ
ಮಾಡ್ತೀನಿ
ಸರ್. ಒಂದ್ ನಿಮಿಷ ಸರ್, ಮತ್ತೆ ಅನ್ಮ್ಯೂಟ್ ಮಾಡ್ತೀನಿ ಸರ್ ನಾನು ನಿಮ್ನ.
Dr. Diana, we are really thankful to you for coming over here to deliver an interesting talk. Of course, I'm surprised to see here we have been doing research in only one direction, either in the temperature or maybe a diseases. But I really appreciate your attempt making use of both the temperature and disease in together, making a silkworm larvae resistant to both diseases as well as the temperature. So in this way, whatever the attempt you people are attempt making, so undoubtedly I could say that you might come out with a good breeds which can be useful to the silviculture industry. So my single question is, when you put the silkworm larvae for high temperature as well as a disease resistance, so what is the rate of this productivity, whether increased or decreased against individual component?
Individual component means?
In the sense, if you expose only for temperature resistance or disease resistance, could you find out any difference among these two?
No, we have subjected the evolved breeds and their crossbreeds simultaneously after stabilization. We have simultaneously, just to our curiosity, if you expose the developed or stabilized breeds and crossbreeds simultaneously in a single generation for both this biotic and abiotic stress, there will be small marginal variation we find. I shown the data. There will be a 1 day shorter larval duration in case of stress treatment. Mainly because of the high temperature, because we are exposing the silkworm larvae to high temperature of 36 degrees.
High temperature as well as the disease together, therefore there is a combined effect.
There is a combined effect.
Thank you.
Very good.
Sir, Basaraj sir, you can ask the question, sir. Basaraj sir, over to Basaraj sir. Basaraj sir.
Hello,
Yes, sir.
audible?
Audible, sir. Tell me, sir. Good morning, sir.
It is audible,
Good
sir.
morning. Dr. Dayanand,
Good morning, sir.
for a very good presentation. The overall scenario of silkworm breeding, both conventional and biotechnological approaches.
Thank you very much, sir.
What I would like to say is quite a good number of silkworm breeds and hybrids, both polyvoltane and bivoltane hybrids, have been developed all over the world and identified for specific seasons and all that. But the temperature tolerant and disease tolerant, it is very difficult to, as per my knowledge goes, to incorporate all desirable characters or cumulative characters in 1 or 2 breeds. The targeted traits we can improve considerably. That is one aspect. The another thing, what you have told, the breeding procedure for high temperature tolerance and all that, that this CSR 18, 19, 46, 47 has been bred accordingly and tested 5 lakhs in the field. When farmers have reared the productive hybrids, they get a little low yield and low cocoon traits. Then they said, no, we will manage in the rearing manipulation. I will rear only the productive breeds. Like that, gradually these hybrids have been withdrawn. Keeping in view of this, in addition to the silkworm hybrids role, the manipulation of temperature and humidity during adverse conditions yield better than the breed which can adjust the high temperature and high humidity and giving good result. This is my views on this.
Definitely, sir.
Coming to the polyvoltane hybrids, you said quite a good number of breeds. Other than Mysore into bivoltane, any bivoltane with Mysore race, why we are not being able to successful even this also, though they are productive and all that. The important characters, if you observe the Mysore race, the number one is the uniformity of cocoon weight of both male and female. Male is, if you assess 100 males, very little you get standard deviation. Similarly, the females. That's why, the emergence pattern, bimodal emergence is quite good, easy to handle. That is one advantage. That has to be incorporated in our new breeds or hybrids, what you told about polyvoltane to polyvoltane. This is one my observation. So many hybrids have been developed, both KSSRDA, Mysore Institute, and other, even Barampur also. But still, we are not able to go out with Mysore into biovoltane and Nistar into biovoltane. This is one aspect. Please take care. In both, Nistar also similar phenomenon. For example, you assess the 100 cocoons, seldom you get any standard deviation in males and also the females when you take the mean values. This is one important aspect you have to study. Coming to the disease tolerance, this also, how disease occurs. It occurs only due to pathogen. Without disease will not come. But to avoid pathogen, as you rightly told, very systematic disinfection and good incubation, good chaff clearing and all that. Where do they come pathogen then? This is another question. And also a farmer who harvests less defective cocoons. What do you say about good quality cocoon? A farmer who harvests less defective cocoons. Defective cocoons, how it occurs? It's also same phenomenon. So in this aspect also, what you are told is very good. It is a good line for young scientists to take up future breeding program. So in this, you have enlightened the breeders, and you have told very nicely the earlier work, what we have done, what earlier people have done, and how to take further to develop this, what you call the need of the hour, disease tolerant and temperature tolerant. It takes little tough. Quite a good number of breeds have been developed. For example, when you are in Japan, Matsumoto Institute, they have developed so many breeds, high temperature, but none of them are accepted by the farmers. Only when farmer accepted the hybrids, either disease resistant or productive breeds or temperature tolerance, then only it's a successful breeding program. This is my views. Thank you. Thank you for your good presentation.
Thank you for your feedback, sir.
Yeah.
So any questions?
Ramya VS.
Ramya, you can ask the question.
Hello.
So anybody wanted to ask the question, please raise your hand.
They can unmute. They can unmute themselves and they can ask the question.
You can unmute and you can ask the question. Speaker is waiting for the questions.
Feedback.
Please raise your hand. If you want to ask the question, please raise your hand. Unmute yourself. You can ask the question.
ಎಷ್ಟು ಜನ ಪಾರ್ಟಿಸಿಪೇಟ್ ಎಕ್ಸೆಪ್ಟ್ ಬಸವರಾಜು ಸರ್ ನಾನು ನೋಡಿ ಬೇರೆ ಯಾರು ಗೊತ್ತಿಲ್ಲ ಅಲ್ಲ ಅಲ್ಲಿ ಆಕ್ಚುಲಿ ಬಸವರಾಜು ಸರ್ ಒಬ್ಬರೇ ಅಲ್ಲ ಬಸವರಾಜು ಸರ್ ಒಬ್ಬರೇ ಇರೋದಲ್ಲಿ ಕರೆಕ್ಟೆಡ್ ಪರ್ಸನ್ ನಮ್ಮ ಇವರು ಮಂಜುನಾಥ್ ಸರ್ಗೆ ಹೇಳಿದ್ದಿಲ್ವಾ ಈಸ್ ಟು ಆಲ್ವೇಸ್ ಸುಬ್ರಹ್ಮಣ್ಯಂ ಸರ್
Dr. Dayanand,
sir.
One suggestion with regard to the new breeding approaches,
Yes, sir.
Using the silkworm genetic material, crossing with our donor parent or recipient parent, whatever it may be. Instead of that, what I suggest, Dr. Dayananda, use the hybrids which have been commercially authorized in advanced countries where they have taken more related. So such type of hybrids you can obtain, start breeding program with highly segregating population. That will give a better result than the using single genetic material with recipient parent or donor parent.
That means you have to use one local and one outside hybrid in combination, sir.
That then not like that. You should use their hybrids directly as the breeding resource material.
Yes, sir. For the development of the new breeds.
Because why I'm telling this one, this is what in JICA we have resulted 47 breeds, utilizing all hybrids which have been commercially authorized in Japan, not as a parental breeds or genetic material or pure races. From hybrids, when you inbred F2 population, highly segregating, that's a branch segregation. You can choose any desirable genotype. So that will help. And another added advantage, they have taken more care on reeling parameters which are related to breeding, the quality of filament length, whatever it may be. That is added strength for the breeders when you use hybrid as a breeding resource material. This is my views of my experience.
Definitely. But now we are having that Bulgaria breeds with us, sir. So we try with those things, sir.
Okay, fine. So that type of breeding is useful. Otherwise, single parent crossing with another parent, it is not going to help much.
Yes, sir. Thank you very much, sir.
Thank you.
Any questions? Dr. DM, sir. Over to DM, sir.
Hello, good afternoon, Dr. Dayanand.
Good afternoon, sir. How are you, sir?
Oh, fine, thank you. How about you?
Just now I asked.
So it was a nice presentation from your end.
Thank you very much, sir.
My compliments to you for the beautiful presentation with lot of information and having concentrate. Hello.
Tell me, sir. Audible, sir.
So you have concentrated on the improvement of production and productivity apart from disease resistance, especially against BmNPV. And see, when we look at the silkworm breeds, generally everyone knows that two factors will prominently figure. One is the productivity, second one is the disease resistance. And when we look at productivity, disease resistance means when we aim at higher productivity, disease resistance will be lower because they are negatively correlated.
Definitely, sir.
As Dr. Basraj rightly puts it, the greatest advantage one can derive is from our pure Mysore, which has the highest level of BmNPV resistance. And even the expression of BmNPV is not due to temperature, high temperature alone, or high temperature coupled with high humidity. There are quite a few factors or stress factors to be considered in silkworm diseases. Even apart from high temperature, high humidity, even when you conduct silkworm rearing under crowded condition, crowding becomes a serious stress factor in the expression of NPV. And even the nutritionally inferior mulberry, because the quality always matters.
Yes.
That is a universal application whether it's a silkworm or human being or any other organism. The food plays a very important role, the nutrition factor, and the nutritional components should match with the nutritional requirement of the silkworm. then only the silkworm can survive better and perform better. That's why, of course, a lot of emphasis has been laid on this aspect that the nutritional factor has been always in the forefront, developing quality and productive mulberry through appropriate agronomical practices, all those things. So we have to, it is not a single thing that we have to consider, as you have already indicated. The whole expression of the or ultimate the result what we get, it is the interaction of many factors. The breed related factor means the genetic factor and the environmental factor. There may be genetic possibility of expression of the disease, but if the environment is not favorable for it, so the disease will not be expressed. Anyway, it is very difficult to have a single factor taken into the highest level. Anyway, if you want to improve productivity, you have to sacrifice the survival and vice versa. Anyway, you have done a lot of research through a molecular approach, conventional breeding, a lot of things. I do not know because I am not a breeder, but I know a little bit about the disease aspects. But NPV is a very peculiar this one. When it comes to biotin production or biotin propagation, we have to be more careful in tackling the NPV because the expression is more in productive breeds. That's why. So NPV sometime one would not be knowing where exactly, as Dr. Basura said, despite conducting disinfection very scrupulously, using appropriate disinfectants and following all new technologies for chalky rearing, and then adoption of the technology for adult-age rearing and all that, the expression of the disease is seen. How does the pathogen expresses when you do all those things? So these are some of the things to be known, isn't it? Because you are creating a sterile environment when as far as the pathogen presence is concerned, but still the disease is expressed. Where from? Does it appear de novo? Means from nothing, the disease has to come. That looks very difficult to understand and explain. So these are some of the things to be known. I do not know for sure how exactly the disease expresses even under sterile conditions with the best of the rearing practices. So anyway, it's a very nice presentation from your end with a lot of information, and I'm indeed thankful. I'm very happy and also thankful to you and the faculty of the Department of Sericulture, Dr. Sannappa, Professor Manjunath, Dr. Anil Kumar, and others. And I'm also thankful to the delegates who have interacted in a very serious manner, especially Dr. Basuraj, because he is a breeder par excellence. I know, silkworm breeder, and with lot of commitment and devotion, sincerity. Those things cannot be questioned when it comes to Dr. Basuraj. Anyway, so it's a nice thing that I'm here today with you people. Thank you. Thank you.
Thank you, sir. Thank you very much, sir.
Any questions from student side?
Hello.
Hello.
Please.
Hello.
Hello, tell me, sir.
Good morning. I am Dr. Madhava from KSSRNDI.
Hi, very good morning, sir.
For a very good presentation, sir. I am thankful to Dr. Manjunath also for making such arrangements.
Very good.
Okay. I have one minor question. Sir, in polyvoltaic breeding, you are increasing the productivity traits. Keeping the survival constant, you are increasing the cocoon weight, shell weight, and CSR, as I saw in your presentation. What is the percentage of hibernation in winter season, sir, in your polyvoltaic races?
I am not dealing with any hibernation parameter here.
The percentage of occurrence in the polyvoltaic in general, I am asking.
Sir, in which breed? It may vary from breed to breed and season to season. Only in the winter, earlier we used to get some 3% hibernation in the new breeds. Because this hibernation is also it is going polyvoltaic. It is going for hibernation means it is an indication of the productivity. Is it not?
Yes.
That's why gradually it has to be reduced through selection pressure by application of selection pressure. Only around 3% earlier used to get from MV1. Of course, at the time of stabilization, you used to get some 15% of hibernation in that particular season in the winter. But afterwards, through our efforts, gradually now, absolutely, there will be no hibernation. If at all, if it is there, hardly it is negligible incidence.
Thank you, sir.
You are having any problem of hibernation in the polyvoltaics there?
No. Presently, we are not getting any such incidences. Previously, we had. So now it is by continuous selection. We have reduced it.
But moreover, it is not a heritable character.
Okay.
It is not a heritable character. In polyvoltaic, whatever you are getting hibernation, that is not carry forward to the next generation. Is it not? If you are having,
okay.
Tell me, sir.
Okay.
Tell me.
We observed just in few races, we observed hibernation potency.
Because it needs stabilization. It takes time. It takes time, but always you should take care of that. You have to apply that selection pressure. It is not a heritable.
Will it not reduce the productivity?
Definitely, it is an indication.
Okay.
It is going for hibernation means it is having productive traits.
Okay, sir. Thank you very much.
That's why I used to, Dr. H.K. Basuraj sir used to tell that multivoltaic that cocoon traits, it need not to be go beyond your prescribed level. If you go beyond your prescribed level, this trimolters and then this hibernation will come into the picture.
Okay, sir.
Okay, thank you.
Okay, nice presentation, sir.
Thank you very much.
Any questions from students?
Hello. May I come in? Hello.
Sir. Zafar.
Hello.
Dr. Zafar.
Yeah, Dr. Zafar Iqbal from Sericulture University of Agriculture Science and Technology, Kashmir.
Okay.
Sir, I just want to congratulate my teachers, host of the teachers of this program. So it was really a very wonderful presentation. So I just thank my teachers for conducting such programs, and I hope these programs will continue from University of Mysore. It's an honor to me for being there with this program. Thank you very much, sir. Thank you.
Thank you very much, Jafar. Thank you very much.
Thank you, sir. Thank you, sir.
If there is any.
And no question. If there is no questions, I will wind up the program. I will conclude the session. Okay. Last part of the session is vote of thanks. Now, sir has given informative talk on breeding strategy for the development of silkworm breeds tolerant to high temperature and BmNPV. Really, it helps us to enrich our knowledge, particularly research scholars and MSc students. They make use of the informative talk, sir. So, on the behalf of faculty members of Sericulture Department, research scholars, and the students of Mysore University, and on the behalf of all the participants, I thank Dr. Dayanand sir for giving inspired talk. Thank you one and all. Thank you, sir.
Thank you.
I would like to express my special thank of gratitude to the university authorities extending facility to successful completion of this program or the webinar. Thank you one and all, sir. Thank you very much. ಅವ್ರಿಗೆ ಹೇಳ್ಬಿಟ್ಟು
ನಮ್ಗೆ ಬೇಡ ಸರ್
ಮಾಮೂಲಿ